Hello everyone. Before starting the lesson, try the warm-up. Simplify the following expressions. These are the expressions I'd like you to simplify. Use this triangle to do so. So, pause the video and try this. Just remember that angle A has side A as its opposite side. Angle B across from that is side B, and here's angle C across from that is side C. So we have the values for A, B, and C that we can plug in to our expressions. And angle A, angle B, angle C, we know what they are from the diagram. So once we have filled in the missing values, we can use the fact that these are those special angles that we have a chart for. We can find out what the sine of 60, the sine of 30, and the sine of 90 are, plug those in, and then simplify our expressions. The sine of 60 is root 3 over 2, the sine of 30 is 1 over 2, the sine of 90 is 1. So when you simplify this, remember if you're dividing by a fraction, that's the same as multiplying by the reciprocal. Root 3 times 2 over root 3, those cancel out, you're just left with 2. In fact, 2 is the answer for all of these when you simplify. Now this should be no surprise if you remember something called the sine law. A over sine A equals B over sine B equals C over sine C. The ratios of sides and their angles that are opposites is the same for each pair of angles and opposite sides. This is the sine law. And the sine law is one of the trigonometry laws that we're going to look at in this lesson. We're going to look at the sine law and the cosine law. You might remember these from grade 10, and we're going to review how to use those in this lesson. We're going to use the sine law and the cosine law to determine missing sides and angles, and we're going to talk about something new. We're going to identify when to consider the ambiguous case. We're going to talk about what that is and when to consider this. So let's start by reviewing the sine law. And we saw this in the warm-up when I matched up angles with their opposite sides, and I wrote them as a ratio of the side length to the sine of the angle. I got the same answer for each pair. So that is the sine law. Now we see three different ratios all equal to each other, but when you're actually using the sine law, you're just going to be using 2 at a time to solve for an unknown. But we'll get to some examples for that. The other law that we're going to talk about in this lesson is the cosine law. C squared equals A squared plus B squared minus 2AB cos C. You learned this in grade 10. It looks kind of like the Pythagorean theorem, at least it starts to look like it, but then we have this adjustment because we're not dealing with right triangles all the time. One thing about notation, we use capital letters for the angles and lowercase letters for the side lengths. So whether it's an uppercase or a lowercase letter actually matters. It identifies whether you're putting a side length or an angle in these positions in these laws, whether it's the sine law or the cosine law. Now the cosine law is written like this. This is set up nicely for finding a side length. We could do some algebra to rearrange this equation to solve for a missing angle. If I have c squared equals a squared plus b squared minus 2ab cos c, I can rearrange, have positive 2ab cos c, move this to the other side, it becomes minus c squared. To solve for cosine of c, I divide by 2ab, and I end up with this. So when I'm writing the cosine law, I can write it this way, or I can write it this way. It's the same equation, just rearranged. The reason I would want to write it this way is if I'm trying to find an angle. I don't have to do any rearranging, I've already done the rearranging. So let's go through an example. Determine the length of side A. Well, here's side A. We want to find this side length. Now, one thing that you want to start with in any of these problems is to see if you can have matching pairs. And what I mean by matching pairs is like I'm showing you. You have an angle and its opposite side matched up. Angle, opposite side. If you know a complete pair, then you can use the sine law. Now, you might be looking at this and think, well, in this pair, I don't know everything because I don't know what A is. And in this pair, I don't know everything because I don't know what angle C is. So I can't use the sine law. However, notice that we already know two angles inside this triangle. Always keep that in mind, that the three interior angles of a triangle add up to 180 degrees. So if you know two angles, you automatically know the third angle. In this case, it's 52 degrees. So now, look what I have. I have a complete matching pair. I know an angle and its opposite side. If you know that, you can use the sine law. So the sine law, remember, it's side divided by sine of the angle. Look at our matching pairs. A matches with 84, so A over sine 84. 6.7 centimeters matches with 52 degrees, so 6.7 over sine 52. We don't have to do the third pair because we don't know what this side is anyway, so we would just have another unknown that we don't need. This equation has enough information that we can solve for A. Because it's a proportion with one unknown value, we can cross multiply. Multiply the diagonal. 6.7 times sine 84 is equal to A times sine 52. Then to solve for A, you got to divide by sine 52. So shortcut, multiply the diagonals, divide by the number left over. So A is equal to 6.7 times sine 84 divided by sine 52. That's what I wrote here. So now I just plug that into the calculator and I get about 8.5 centimeters as the value for the side length A. Just to recap, if you can match up angles with their opposite sides and you know a complete pair, you can use the sine law. And once you're using the sine law, you cross multiply to solve for your unknown value. Here's a different example. Determine the length of side X. Here's X, it's this side length here. So just like before, we want to check to see if we can find matching pairs, to see if we can use the sine law. Well, X matches with the 49-degree angle, 3.8 centimeters matches with angle Y, 4.6 centimeters matches with angle Z. I only know one angle, so I can't subtract from 180 to figure out what either of these angles are. So because I can't figure out what these angles are, I don't have a complete matching pair, which means I can't use the sine law. So I'm going to use the cosine law instead. Now I'm rewriting the cosine law as I did on the previous slide, just so you can see it again, but you should have this recorded in your notes so you can refer to it. I'm going to use this form of the cosine law because it's set up to find a side length, which is what I'm trying to find. Remember, the labels A, B, and C are just arbitrary. C just represents the side length that I'm trying to find. A and B simply represent the other two sides. It doesn't really matter which one you call A and which one you call B. But wherever you see an A or a B, you're inputting the other two sides. Angle C is the angle that's opposite side C. So if this is side length X that we're trying to find, it's opposite the 49-degree angle. That's the angle that we put here. So now I just input my values from the diagram. X is the side I'm trying to find. A and B are the other two sides, 3.8 and 4.6. The angle is 49 degrees. I can put this whole expression into my calculator and see what I get. You're going to get a value approximately equal to 12.6642. Now, at this point, don't clear your calculator. Just keep whatever you have, as many digits as possible, so that you don't lose precision in your final answer. But remember, this is what x squared is equal to. So now, to solve for x, I have to take the square root, and I get approximately 3.6 centimeters as my final answer. So we always check to see if we can use the sine law if we have a complete pair of an angle and its opposite side. We didn't have that, so we can't use the sine law. That's how we knew to use the cosine law. And because we're finding a side length, I used this form of the cosine law. You plug in your numbers, use your calculator, solve for x. And just a side note, some people might be wondering, why did I not do the plus or minus square root here? Well, think about what you're doing. You're finding a length. It doesn't make sense to have a negative value as your answer for a length, so that's why we're only taking the positive square root at this point. So in the last two examples, we were looking at finding a missing side length. In this question, we're determining the measure of angle A. So this time we're finding this angle right here. Always start out by looking for these matching pairs though. Angle A, the one we're trying to find, matches with 4.8 centimeters. Angle 80 degrees matches with 7.5 centimeters. Well, look at that. I have a complete matching pair. That means I can use the sine law. So when I do that, I'm doing what I did before when I used the sine law. I turn my matching pairs into an equation. Angle A matches with the 4.8 centimeters, so 4.8 over sine A is my ratio. The 7.5 centimeters match with the 80 degree angle, so 7.5 over sine 80 is my other ratio, and they're equal. Like before, I can solve for my unknown by cross multiplying. And when I do that, remember, sine A is the unknown in this proportion. So I'm going to multiply the diagonals, 4.8 times sine 80, and I'm going to divide by 7.5. So when I do that, I get approximately 0.6303. Now don't clear your calculator at this point because we're not done. Remember, this is what sine of angle A is. We want what angle A is. So we have to do the inverse sine of that number. So don't clear your calculator. Just use your shift button or your second function button with the sine button to access the inverse sine function. If you have trouble with that, meaning you don't get an answer of about 39 degrees, then you should reach out for help on how to input this into your calculator before you keep continuing on in the lesson. But just to reiterate, always look for matching pairs of angles and sides first. If you have a complete pair, you can use the sine law. Once you do that, you cross multiply to solve for your unknown. And last step, if you're finding an angle, you have to do the inverse sine to get the angle at the end. In our next example, we're still determining the measure of an angle, but this time it's angle X in this new triangle. So start by looking for matching pairs of angles and sides. In this triangle, we don't know any angles. So we can't subtract from 180 to find one of the missing angles or anything like that. We just don't know any angles. So we cannot use sine law because we can't have a complete matching pair. So instead, we're going to use the cosine law. Now this time we're trying to find an angle. So because I'm trying to find an angle, I'm going to use this form of the cosine law, the rearranged form, because it's set up nicely to find a missing angle. So just remember, the capital C just simply represents the angle that we're trying to find, x. A, B, and C are the side lengths. Now just keep in mind, angle C and side C are opposites. So if we're trying to find angle C, side C is the opposite side to that angle. For us, we're trying to find angle X. The opposite side is 62. So that 62 has to go in this spot in the cosine law. A and B are just the other two sides, 52 and 46. It doesn't really matter which one you put where, as long as you use both of those other sides in the A and B positions. The really important part is that for whatever angle you're trying to find, this is the opposite side. So you plug in your values. The angle we're trying to find is x. The opposite side is 62. A and b are just the other two sides, 52 and 46. Now, I always recommend that you work this fraction out separately for the numerator and denominator instead of trying to do this entire calculation all at once. Because if you're not putting brackets around the numerator or brackets around the denominator in your calculator, it's not going to work out properly for you. So just calculate the numerator, 52 squared plus 46 squared minus 62 squared, it's 976. And through the denominator, 2 times 52 times 46, that's 4,784. Now, this fraction is the cosine of angle x. So we have to do that last step of the inverse cosine to get the angle. And it should be about 78 degrees. If you try this in your calculator and you're not getting 78 degrees approximately, then reach out for help before you move on so that we can figure out what the issues are. Okay, in this example, we have a triangle ABC. We're given the information that angle A is 36 degrees, side A is 4 centimeters, and side C is 6 centimeters. We're asked to draw the triangle and calculate angle C. So let's start by drawing the triangle. If you try to draw this triangle, it's not clear whether this angle here is acute or obtuse. Both drawings are possible. We don't know which one is the correct drawing. This is called an ambiguous case. Ambiguous just means you're not sure. So the case for this triangle is one that we're not sure of. We don't know if we have an acute angle here or an obtuse angle there. So really, to answer this question, to calculate angle C, we have to solve both possibilities. Now, it's easier to start with the acute possibility. We have a complete matching pair angle with opposite side, and we can use the sine law to solve for angle C. So when I use the sine law to solve for angle C, I end up with about 62 degrees, which is an acute angle, which matches my drawing. But I want to remind you of the cast rule. Remember the cast rule for angles in the 4 different quadrants. This acronym CAST tells us which trig ratios are positive. In the first quadrant, for acute angles, less than 90, all of them are positive, sine, cosine, and tangent. In the second quadrant, these are our obtuse angles. Only the sine is positive. Cosine and tangent are negative. Now, how does that relate to this? Well, look right here. Sine C equals 0.8817 approximately. That's a positive value. So the sine of angle C is positive. Well, where is it positive? In quadrant 1 and quadrant 2. Now, when we put this in our calculator, and our calculators told us that angle C was 62 degrees, that's only telling us the value in quadrant 1. But remember, we could also have an angle in quadrant 2 between 90 and 180. So if there's 62 degrees between the x-axis and the terminal arm, it's the same on the other side. This is going to be 62 degrees less than 180 degrees. So if I subtract 62 from 180, I end up with 118 degrees. And that is the other possible value for our angle, which is an obtuse angle, matches my second possible drawing for triangle ABC. So when I calculate angle C, there's actually 2 possible answers. Now, by extension, I could now solve for angle B in each case, knowing that all 3 interior angles add up to 180. And you'll see I get different values for angle B depending on whether I'm dealing with the acute triangle or the obtuse one. So just to recap, in a triangle, if you know an angle and two sides, just watch out. It might be an ambiguous case. If it is, when you get to this point here and you take the inverse sine to find your angle, just be aware you should also subtract that from 180 to get the obtuse possible angle as well. Now, how do you know if you're dealing with an ambiguous case? A triangle is ambiguous if you know two sides and an uncontained angle. So here's a drawing to represent that. Here's a side, here's a side. This angle is uncontained, meaning it's not in between the two sides. So you can remember that SSA, or you can work backwards, and I'll let you sound out that acronym to help you remember how to know whether you're dealing with an ambiguous case. There are special cases that are not ambiguous. So here we have a triangle where I have two sides and an uncontained angle. This would not be ambiguous if side length B, the one across from your angle, is greater than or equal to side A. So equal to A, you would have an isosceles triangle. That's not ambiguous. Or if this side length is longer than this side, it's not ambiguous. Also, if you're dealing with a right triangle, it's not going to be an ambiguous case. Because this is a right triangle, the other two sides have to be acute angles. But in general, if you have a triangle and you know two sides and an uncontained angle, look to see if it's an ambiguous case. And you're going to have two possible answers for some of your angles in the triangle. Now this last example is an example of a word problem, and a lot of people struggle with word problems because they get bogged down in the words, in the description. If you can imagine what's happening in the situation, it's often a lot easier. Once you have the triangle drawn, it's easier to figure out what you're dealing with. In this example, I'm giving you a drawing just to make the video a little easier, but if you're dealing with practice questions later that don't give you a drawing and you have trouble coming up with the drawing, that's something that you can get help with. Okay, Bob's campsite is 15.6 meters from a lake and 36 meters from a lookout. So here's the campsite, here's the lake, here's the lookout. The lookout is directly east of the lake. So directly east, if we look at a compass, there's north. East would be at a 90-degree angle to north. From the lake, the angle between the campsite and the lookout is 140 degrees. So from the lake, here's the lake, the angle between the campsite and the lookout, okay? From the lake, you're looking at the campsite, you're looking at the lookout. The angle between those two places is 140 degrees. Bob hikes from his campsite to the lookout. So he's walking along this route. What is the bearing of the lookout from his position? Now I want to just talk about this word bearing. If you're not familiar with orienteering or using a directional compass, you might not be familiar with what a bearing is. A bearing is simply an angle from north. So if north is this way on the map, the bearing would be the angle from north down to where you're walking. So on the drawing, angle NAC, from N to A to C. That entire angle in there is what we're trying to find. So I hope you can see how the drawing actually relates to the description in words, and that might give you some help later on, but again, you can get some help with other word problems if you need it. Once you've got the drawing, the rest is fairly straightforward. You have an angle that you're trying to find. Now, it just so happens in this one, it's a little more difficult, a little trickier, because the angle we're trying to find ultimately is not part of the triangle fully. This part is, but this part is not. It's outside the triangle. So it's going to throw a little twist into this problem, but really we're just trying to find this angle. So we need to figure out what this angle is, and once we know that angle, we can use it to figure out the entire angle that makes up the bearing. Now, I'm going to give you a chance to pause the video and try this on your own. First step, just see if you can figure out what this angle is right here. I'm not showing all my work here, but first thing I notice is that I have a matching pair, angle with opposite sides. So I'm going to use the sine law. The 15.6 meters matches up with angle C. So I'm going to first find angle C using the sine law, and I get about 16 degrees. Because this is 16 degrees and this is 140 degrees, I can figure out what this angle is. Subtract from 180, I get 24 degrees. So now I know this angle right here. Now you might be wondering, is this an ambiguous case? I know two sides and an uncontained angle. So should I use two possible drawings for this? Well, remember those special cases that are not ambiguous? The side across from the angle that you know, if it's longer than the other side, then it's not ambiguous. So this angle here must be acute. It will be 16 degrees. It won't be the obtuse version. Also, if you tried doing this, subtract this from 180, you would get another obtuse angle here. You can't have two obtuse angles in a triangle, otherwise your interior angles would be more than 180 degrees. So that's how I knew that this 16 degrees was the only possibility for angle C. So now we have to find the bearing of the lookout from his position. So we need to know this angle from the north line down to the path that he's walking on. This angle here. We know this part of it is 24, but we need to know this part to add them together to get the entire bearing. Now I'm just going to redraw this over here so it's less cluttered so you can see what it is that I'm going to show you. Now you might not immediately recognize this, but I'm stemming from the fact that the lookout is directly east of the lake. So this line here is directly east of this line, the north-south line, which means that it's at a 90-degree angle to the north-south line. Now, if I drew another line here that's exactly east from the north line, that means this line is parallel with this line. Now, you may or may not recall when we're dealing with parallel lines, we have these different patterns. Here I'm highlighting a Z pattern, which means that these alternate angles are equal. Okay, so we figured that out, but what's this angle in here? Well, remember, north-south line, east-west line are at 90 degrees to each other. So if the entire angle from here down to here is 90 degrees, I can subtract this and this from 90, and I get 50 degrees. 50 plus 24 plus 16 is 90 degrees. So with all that being said, I can finally figure out what angle NAC is from N to A to C. That's a combination of 50 and 24 degrees. That adds up to 74 degrees. So now I can finally answer the question. The bearing of the lookout from his position is 74 degrees. So this question had a lot more complexity than the last examples, but I wanted to show you that you can find out what the triangle is, use either the sine law or the cosine law to solve for numbers in that triangle. And then if you have to work outside the triangle, there are ways to do that too, which you might need to rely on your past math experience to do that. But the practice questions that go along with this lesson deal with sine law and cosine law. So you have to be comfortable with knowing whether you're going to use the sine law or the cosine law in order to answer your question or to solve a problem. Also, watch out for the ambiguous case. If you know two sides and an uncontained angle, you might have an ambiguous case in which you'll have two possible answers. So look out for that as you're practicing, and if you need any help, reach out and I'll do my best to help you.